Hi everyone, in today's video we're going to be discussing helpful hints for sequences of transformations. So the first thing we should always do is line up letters. Next, always be specific and don't write down reflection. Make sure you write down reflection in the x-axis or the y-axis. Always be specific as possible. Next, explain or describe means use words. And remember, a sequence means more than one transformation. So you have to have multiple transformations. Let's take a look at the first example. Quadrilateral MATH and its image M double prime, A double prime, T double prime, H double prime are graphed on the set of axes below. Describe a sequence of transformations that maps quadrilateral MATH onto quadrilateral M double prime, A double prime, T double prime, H double prime. So the first thing I see is sequence of transformations. So I know that it has to be more than one. So I'm going to put a 1 in my pre-image and a 2 in my image. So I notice here that there is a turn, so I know there has to be a rotation. If I'm in quadrant 1 and then I end up in quadrant 3, remember each quadrant you rotate is 90 degrees. So to go into the second quadrant, it would be 90. To go into the third quadrant, it'd be a rotation of 180 degrees. So again, roughly, I'm going to just sketch where it would kind of look like. Somewhere there. So I know there has to be a rotation of 180 degrees. But remember, we can't just have one transformation. It has to be multiple. So I take this point here and I have to get it here. So I have to go up one to the left one, which means there has to be also a translation 1 unit up, 1 unit left. You could write this also as a rotation with a capital R of 180 degrees, and then a capital T of 1 unit to the left would have to be -1, and 1 unit up would have to be 1. Now, I'm missing one thing. Remember anytime I do a rotation, I have to say where it's centered at, and for here, our center of rotation is at H. So I have to make sure I write that down as well. So I'm going to say rotation of 180 degrees centered at H. So don't forget that part as well. Don't forget there's also other ways to describe the sequence of transformation. You could have also said it was a reflection in the origin. Let's take a look at the next problem. Number 2, on the set of axes below, triangle ABC is congruent to triangle STU. Describe a sequence of rigid motion that maps triangle ABC onto triangle STU. So again, notice it says a sequence of rigid motion, so it has to be more than one transformation. So if you take a look at this diagram, I notice that the triangle is being turned. So if I start in triangle ABC, that's 1, and I have to get to triangle STU, I see that it's being turned, so it has to be a rotation. So let's figure out what that is. I'm going to say my center of rotation is going to be at B. So notice the distance from B to A, I will go over 2 to the right and then 1, 2, 3 up. I would do the opposite if I was rotating 90 degrees. So I'm going to go up 2, and over 1, 2, 3. That's going to be A prime. The distance from B to C is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 to the left. So this is my new triangle after a rotation of 90 degrees about point C. So we do rotation of 90 degrees about point B. Then how do I get triangle A prime, B prime, C prime to triangle STU? So let's remember that ABC and STU, we can line up the letters. How do we get A to go on to S, B onto T, C onto U? So let's see. A prime to S is over 1, 2 to the right, and 1, 2, 3, 4, 5, 6 down. So that's going to be a translation of 2 to the right and 6 down. You could double check this with the other points. So C corresponds to U, so let's go over 1, 2. 1, 2, 3, 4, 5, 6 down. And finally, we can do that for B going to T. Over 1, 2, down 1, 2, 3, 4, 5, 6. Again, if we wanted to use the notation, we have capital R, 90 degrees, about point B, and then a translation, capital T, of 2, comma, negative 6. Don't forget there are other ways to answer this problem.